All right, so now we want to test claims about means. And the structure of hypothesis testing is the same for testing claims about means as it is about for testing about that we use for testing proportions. All right, we have a couple differences, and I'll illustrate those with a couple of different examples. The first set of situations that we want to look at is we want to test claims. So we want to look at hypothesis testing um, where sigma is unknown. And in fact, this is the case that it most often happens. We don't know the population standard deviation. This is the way that we most often work. So that's why we spend most of our time on it. Um, the big difference here, if sigma is unknown, I'll just write it here so you can remember this. The test statistic is the t-score. Okay, so if sigma is unknown, the test statistic is the t-score. Whereas if sigma is known, the test statistic is the z-score. Again, we don't use that method as often. We use this method more. So here's the problem we're going to look at. We're testing the effectiveness of a weight loss program, and so we want to see if the weight loss program works. So when we test something like this, obviously we're going to have a null hypothesis and an alternative hypothesis. And the null hypothesis is always that the average, because that's what we're looking at. We're considering the average weight loss of people on this plan. The null hypothesis will be that the mean weight loss is zero. Okay, in other words, the plan just does not work. So the mean is zero. The alternative is going to be that the mean weight loss is greater than zero. So that's what we're trying to test, that the mean weight loss is greater than zero. Now, I want you to notice this, as we've always said, the null hypothesis is always that the mean or the proportion equals something. So it's always an equals to here. It's in the alternative hypothesis that you either get greater than or equal to, less than, I'm sorry, greater than or less than. Okay? So just remember that the null hypothesis is always that it's equal to a certain value, and the alternative hypothesis is that it is either greater than that value, less than that value, or not equal to that value. Now be aware, if it's greater than or less than, then we're going to be performing what's called a one-tailed test. So this is an example of how we do a one-tailed hypothesis test. If it's a not equals to, then we do a two-tailed test, and I'll give you another example of that. But we're doing a one-tailed test here. We want to test this at an alpha level or a significance level of 0.01. So what that means is if our p-value turns out to be less than 0.01, then we're going to reject. 0.01, remember, is the probability that we have established as being the cutoff point for getting a statistically unusual or rare event. If the probability is less than 0.01 or 1%, then we classify it as a rare outcome and we will reject. Okay, so moving on. So we have our null and our alternative hypothesis. And real quickly, although I've already said it, here's the sample data. So what we did is we went and got 40 people and that were on the plan, and we found that they had an average weight loss of 3 pounds. So that was their sample mean, and then the standard deviation from their sample was 4.9. Now notice, we don't know sigma, okay? Sigma is unknown. We don't have some little magical standard deviation fairy telling us that sigma equals something. We don't have it. All we have is data from our sample. And so that's why we're using this particular approach where we'll use the t-score. All right? So once you're here, then you're going to calculate your test statistic. That's the next step. You've gathered your data, so now you want to find your test statistic, which is basically convert your data result to the test statistic, either to a t-score or z-score. So the t-score formula looks like this: our sample mean minus the population mean over S over square root of n. We've seen that before. So in our case, it's going to look like this. T equals 3 minus 0 over S over square root of 40. And that is going to equal 3.87. That's the t-score, okay? So once we're there, we want to find the p-value, right? Now you find the p-value. Now, here's where we have a bit of a problem with this. And I guess it's not a problem. In order to find the p-value, we need to use technology. Okay, so if we're using the p-value approach and we want to find the p-value, we need to use technology. Now, we still need to draw the picture because the picture will help us make sure we do things correct. So here's the picture. The claim was that the mean was 0. We found a sample that had a mean of 3.0. And that t-score was 3.87. What we need to find in order to find the p-value is this area, right? This is a one-tailed test, so you're simply finding that area. And this is where our technology is going to come in, and we're going to use our calculator to find that area. We just don't have good enough tables to help us find those areas, so we have to use our table, or excuse me, our technology. So remember, to find areas under t distributions using your calculator, you use the TCDF function. And in this case, we type in the lower bound for our green area. So 3 is the lower or the left boundary. And then the right boundary is some big number. I'll put in 1,000. And then you put in the degrees of freedom. So let me write that down. The TCDF, your first thing is your lower boundary, in comma, your upper boundary of the shaded region, and then your degrees of freedom. And when you do that, we get 0.0, for this problem, 0.0023. So our p-value is equal to 0.0023. Okay? And so once you have your p-value, you compare it to alpha. And notice, so let's write this down. We compare to alpha. And so it looks like this. Our p-value is certainly less than our alpha level, right? And so the rule is if your p-value is less than alpha, you come to the conclusion that you will be rejecting the null hypothesis. In other words, we have found evidence that the mean weight loss is not 0. Okay, and so we will reject. Now, let me just mention real quickly, this is the p-value approach, and the p-value approach requires us to find this area, okay? And to find that area, we need to use our technology. But if for some reason if you wanted to use the critical value approach, the critical value approach you can actually do without technology and do with the tables that we have for t-scores, okay? So everything's going to be the same. You're going to work all the way up till you find your t statistic, okay? So that's your t-test score. So we do all that, and so we have our t-score as still 3.87. We do that the same. But the critical value approach asks us to draw the picture, right? So here's our distribution with the mean of 0. And now we use our table to find the critical value, which is, remember, the table we're talking about is the student t-distribution table, which is the A3. And we're going to use 2 columns. We want the area in one tail. So here's the picture we want. We want some value, right? There's our boundary, so that the area here is our significance level. Okay, so the area here is 0.01. The area in one tell is 0.01. And we just got to remember that we're going to be using degrees of freedom of 39. So if we look at table A4 and go down to the degrees of freedom of 39, we're going to use that row. And then we go across to the column where that matches the area in one tell being 0.01. And so if you do that, that's the second column, 2.426. 2.426, okay? And that's our critical value. This is the critical value approach. Okay, so now all you have to do is you have to say, well, where is my sample? My sample has a t-score of 3.87. That puts it up here, bam, in the critical region. And remember, if our sample lives in the critical region, we are going to reject the null hypothesis, since 3.87 is in the critical region. Now, I just show you these two different approaches because the first approach, you have to use technology really to find the p-value, to find an accurate p-value. The second approach, the critical value approach, lets you use the table that we have, which is fine for the critical value approach, and lets you come to a conclusion. Either way, you're going to get the same result, so we shouldn't be surprised by that. But this is how we do hypothesis testing when we're testing claims about the population mean when sigma is unknown. And also, I'll just mention this one more time, this is a one-tail test. So I'll throw up another example of a two-tail test, and you should watch that. And then another example of when sigma is known, how it changes.